This is Dr. Hiroto Namihira of Dynamic Visualization Technique Laboratory sending about the Black-Scholes formula. A bill with present cost S and interest R changes dynamically. The bill value at a future time t is unpredictable. An optional right to buy the bill at cost k when the bill value is higher than k at time t is sold now. What is the proper cost of this right? This is the program of Black-Scholes. There are three ways to derive the Black-Scholes formula. First, probabilistic model. Second, stochastic differential equation model. Third, heat equation model. Let's show each model's essence visually. The first is an approach with the probability theory. This is the direct description of random change of a bill value. This is a strike price. The second is an approach with the stochastic differential equation. The value change is described with Brownian movement. The value distribution at time t is solved using knowledge of the Ito integral. And the third is an approach with the heat equation. Option price property is derived and proved to obey the heat equation. The heat equation is solved under the boundary condition of option right at time end t. Now we focus on an approach with the probability theory. Suppose a change of bill of unit value in unit time is two-way, that is, upward with probability P and downward with probability Q. The average of the change must be equal to risk-free asset interest R. The variance and standard deviation of this binomial distribution is calculated. We regard the binomial movement as random walk with the average 1 plus R and sigma leap. Now we think about the bill price movement during T terms in which the unit term interest is R and the standard deviation is sigma. A unit term is divided into n small sections, and we think a change of a bill price between the small neighboring section. Let xi mean the bill price at the I small section. The xi is described as follows. by the end of t term, nt times random walk is performed that result various paths because of randomness. This picture is a sample path where r is 0.03, sigma is 0.2, and t is 2. This is called as geometric Brown movement. The bill price at the end of term t can be represented in mathematical form, and we follow its thinking route. Nt times selection is performed until the end of t term, so there can be many paths. But as for the final price, the end of t term, the route that select upward selection k time, downward selection nt minus k times reach the same final result. The probability is this, and the price is expressed as this. Suppose the strike price is k, the option is a right to buy a bill at cost k when the resulting price at the end of term t is greater than k. It is reasonable to set the option cost as the expectation of the option interest. When the final price reach this zone, option right should be used. The average cost is measured at time t, so it must be converted into the present value. Inflation. This expression is what we are asking for. Defining this description goes to the Black-Scholes formula. Among the paths that exceed the strike price k, the minimum route is asked. The smallest index k of the path that exceeds the strike price is expressed like this. Then the option cost is calculated as the sum of all the paths that exceed kt. This is the expression. Red part is expanded using the central limit theorem and finally expressed with the normal distribution. And blue part is also expanded and finally expressed with normal distribution. Summing up the two expansions, we get this expression. Here, kt is assigned, and we reach to the Black-Scholes formula, which may clear the option cost. This is the Black-Scholes formula. Let's try some example. Interest is 0.05. Term is 1. Start. In this case, theoretical option price is 3.05 and simulation 3.2. Good fit. This is the visualized Black-Scholes formula derived from probability theory.